Here we are again. Hi and welcome, my dear friend of the underwater world. Part 4 of this video series. Parts 1 to 3 are of course linked in the video description. I haven't told you this yet, but at the very beginning there was only one video planned on this topic. Now we are at part 4 and we still have 2 more parts to go. Of course, I could have put everything into one video, but I don't think the learning effect would have been as good as I did it now. But I'm digressing now. After we got an overview of the physical basics and the terminology, the parts 2 and 3 dealt with the second stages, one with the downstream valve and one with the pilot valve. Today we are going to tackle the first stages. A first stage has the task of controlling the air from the tank regardless of the pressure prevailing there to a medium pressure that is slightly above the ambient pressure. All types of regulators do this, but in different ways. This medium pressure is then transferred to the second stage, which in turn reduces it to the ambient pressure. We have already looked at this process in more detail. Today we will start with the piston-controlled unbalanced first stage. We have connected our first stage to our tank where there is high pressure. This usually fluctuates between 200 bar and 50 bar. Then we have a medium pressure outlet where the air or breathing gas is fed to the second stage and the inflator via a hose. It is all important that our system has a connection to the environment and can determine the pressure prevailing there. Because of the air pressure provided is too low, our lungs will not be able to inhale it. The reason for this is as follows. The water surrounding us when we dive presses on our chest and we have to use muscle power to fill our lungs. If our breathing gas corresponds to the ambient pressure, we will support it in this. If this is not the case and the pressure of the breathing gas is too low, we cannot exert enough force to fill our lungs. But only in passing. Nevertheless, it fits in well thematically here, because we start with the process by breathing in. The pressure in the second stage drops. We remember, and the air or respiratory gas flows through the medium pressure outlet into the second stage. This empties the chamber of the first stage, creates a vacuum, and the blue spring and the ambient pressure push the yellow piston downwards against the falling pressure inside the chamber. This movement is supported by the high pressure coming from the tank. Now several things happen simultaneously. At some point we stop breathing in, causing this airflow inside the chamber to dry up. At the same time, however, air flows into the first stage through the open high pressure connection. This fills the entire chamber and therefore also presses on the lower part of the piston. An increasing pressure with a constant surface area, as we remember from part 1 of this video series, results in an increasing force, which now pushes the piston upwards against the spring and against the ambient pressure and closes the connection to the tank again. The airflow stops and we have returned to our starting position. As with the second stage, this entire process happens with every breath. This means several times per minute. I would like to mention 2 things that were not explicitly addressed in the process sequence shown. The pressure on the piston through the spring is constant. That means the pressure always corresponds to the sum of the constant spring pressure plus the current ambient pressure. The latter varies, of course. Secondly, it is very clear here that the tank pressure supports the opening process. This in turn ensures that when the tank pressure drops, the pressure on the piston also drops, and the support force is lower the emptier the tank is. It is precisely this characteristic that is referred to as unbalanced. And this is also a good transition to next week, because we will then look at a balanced first stage. With these, it doesn't matter what pressure is in the tank. The breathing capacity to be applied will always be identical. As you are surely already well on the way to become an expert in the field of regulator technology, you can think about what design changes need to be made in order to achieve this. Let me know in the comments if you have an idea and what it looks like. Or wait until next week, and if you have invented something completely new, apply for a patent. Either way, until then, I say all time good air and ciao.